Hi students, in this video we are going to see about the routing algorithms in the computer networks. Yes, what is routing? Routing is nothing but finding the shortest and the cheapest path between the source and destination using either routing algorithms or routing protocols. So with the help of routing algorithm and the routing protocol, we can calculate the routing table. With the help of the routing table, the routers will decide to which link the packets has to be routed from the source to the destination. Clear? So in this session, we are going to see a link state routing algorithm. It can also be called as Dijkstra's routing algorithm. Okay, so with the help of the routing algorithm, how to find the shortest path. That's what we are going to see in this session. Yes, as I said, this is a this is the routing table. So how the routing table is calculated is with the help of the routing algorithm. So see here, if you see this diagram, you can find that router gets the help of the routing table to decide to which through which link the packet has to be forwarded so that it can reach the destination using the shortest and the cheapest path. So every router will be having its own routing table with the help of which it is going to forward each and every packet to the either next hop or to the destination. Yes, as I said, router algorithm determines end-to-end path through the network. Forwarding table, there are two tables, like forwarding table and the routing table. Here they said about the forwarding table also. It determines local forwarding at this router, that is next hop. Whether this forwarding table helps us to find how the best path for the next hop, that is next stop or the next node. This is graph. uh, Graph is equal to n comma e. What is n here? N is nothing but set of the routers. See, all the blue color ovals are nothing but routers, and we have like 3 plus 3 6 routers we have, which can be which are named as u, v, w, x, y and z. And next is set of links. So links are nothing but the interconnection that exists between u and x and u and v, and every link has been uh, given with the cost also. So what is the meaning of that 1 2 2 3 and all is, from u, you travel from u to x or from x to u, what is the cost? That is 1. So to travel from u to v or from v to u, the cost is 2. So this is what the meaning of the cost. Yes. Next, the same thing is explained here. What is the least cost between u and z? Yes. So see this diagram. We have multiple paths, as all of you know. So if you take a source and a destination, we'll be having multiple paths to reach the destination from the source. No need that you have to follow the same path. Why we should not follow the same path, or why we have to follow the same path is, see, if we have multiple paths, when we will be selecting one path is the best path, that is cost cheapest and the shortest path. So among the multiple paths, our routing algorithm help us to select the best path based on the cost. So mostly in the networks, the shortest path or the cheapest path, the best path, right? The best path is decided with the help of the factors such as cost, number of hops, and the distance. So in this algorithm or in the forthcoming algorithms, we are going to take only the cost as the factor to decide the shortest path. Okay, so shortest or cheapest path. Uh, if you see this diagram, from u to z, from u to z, which is the best path? First, to decide the best path, we should know what are the multiple paths that exist between u and z. Among that, which is the cheapest one? We have to check. That cheapest one will be called as the best path. Clear? So from U to Z, if you take, there are different paths. The first path is U to V, V to W, and W to Z. What is the cost? 2 plus 3, 5, 5 plus 5, 10. The second path is U to directly W, that is the cost is 5, and 5 plus 5, 10, the same cost. Then if you take the other multiple path, that is other path is U to X, X to W, and W to Z. So 3 plus 1, 4, 4 plus 5, 9. So if you compare the other two paths with the third path is the best path. Why? Because the cost is less than that is 8 is less than 9. So I'm saying among the three paths I found, actually there are multiple paths. For example, I took only three paths. So in all these three, comparing all these three paths, the third path is the best path because the cost is 8, which is lesser than the other two paths. This is how we are going to calculate the shortest path. Okay. So why we need algorithm? Like this you can calculate manually, right? See, here only we have 6 nodes, so it is possible to do it manually. But if you take Google Maps, it is not the case. We will be having millions of nodes, millions of paths, multiple paths will be existing. So it is not possible to calculate manually. That's why we have automated the system by using the algorithms and protocols. So we have different types in the routing algorithm. The classifications are like this: global or centralized. So what are global? All routers have complete topology. Like every router will be having the knowledge of the entire network. Okay, so how to reach from one source to the destination. That is called global routing. Decentralized is routers no physically connect, only the neighbors. They will not be knowing about the entire network. Or every node or every router will not be having the knowledge of the entire network. It will be having only the knowledge or the cost to reach their own neighbors. That's it. That is decentralized routing. The other classification is static or dynamic. So in static routing algorithm, the always the routes are fixed. Okay, if at all any changes occurs, that they would not be knowing, the routers will not be knowing. So always if you take small children, so if the parents take them in one route, they will go only in that route because they don't know about the other routes. So static is nothing but the router to reach from a particular source to the destination, it will use the same path every time. But dynamic is nothing but, so periodically it will change based on the neighbor's information. The path will be periodically changed. So if at all any traffic occurs, immediately the neighboring node will intimate the source that this path is not best since the traffic is there. Then it will find the other alternative path. So this is dynamic. Okay. So if at all the adults or the parents are going through some route and there if they find any problem, then what they will do, they will go through a alternative path. So this is called dynamic. Static is always they will follow the same path since they don't have the updated information, whereas the dynamic routing, since it has the updated information, how it will get the updates is periodically the information will be updated to all the routers. With the help of that, it will change the paths according to the situation. Okay, so we have three types of routing algorithm. One is link state and the other is distance vector. In the next video, I'll continue this link state algorithm. Thank you. Bye bye.